Hey guys and gals, this next video is going to serve as an introduction to our next unit, which is over quadratic functions. In this first video, we're just going to review what we did with quadratic functions last year in terms of graphing, and we're going to go over how to graph quadratics in standard form. Before I get into quadratics though, I just want to touch base and review what we've seen so far in Algebra 2 in terms of functions. And so listed below here in this box are the equations and the graphs that you should recognize so far. So in our first unit we looked at linear functions, and so you know there's multiple forms of linear equations. Two that you should definitely be familiar with are y equals mx plus b and ax plus by equals c. This is slope-intercept form and standard form respectively. And of course you should know that the shape of a linear function when you graph it is going to be a line. And then also in that unit, we took a look at absolute value functions. And so this was the general form of an absolute value function. Y equals a times the absolute value of mx plus b plus c. And the shape of that graph is going to be a V shape. And so now for this next unit, we're going to look at quadratic functions. There's actually going to be two forms that we look at. The first form today, which is called standard form. And we did this one last year. And then this form right here is called vertex form. We'll look at that in the next video. And quadratics, you should remember, have a U shape, which we call a parabola. So getting a little bit more into quadratics, again, this will all be reviewed for you from Algebra 1. Quadratic function is one in which the largest exponent is a 2. And sometimes we refer to that as the degree of the function. Its degree is 2. Its graph, the name of the graph is a parabola, which again has a U shape. And an equation in the following form, this is going to be called standard form, is what we're going to use to describe a quadratic function. So we have the function f of x equals ax squared plus bx plus c, where a is not equal to 0. Okay, so just let's review some general information about quadratics. Here you can see two graphs of a quadratic, one opening right side up, one opening upside down. And so if you take this standard form equation that we have up here at the top, this equation will tell you a few things about this quadratic function. So first of all, this a value here, sometimes I'll refer to that as the leading coefficient. Okay, and that's just because it's the coefficient on the variable with the highest exponent. It's the coefficient in this case on our x squared. And then we have the b value here, and this entire term right here, the bx term, is what I call the linear term, because this is the term where the exponent on the x is a 1. Okay, so that's called the linear term. And then the c value here, we call that the constant. Okay, and then if we look down here at the graphs, a few things I want to label on the graphs. So first of all, just like absolute value graphs, each parabola has a either minimum or a maximum point. And so we call those points the vertex. In this case, the vertex is a minimum. And over here on this graph, the vertex would be a maximum. The vertex lies on an imaginary line that we refer to as the axis of symmetry, and that's a straight up and down line. So again, if you imagine this, invisible vertical line going directly down through the middle of the parabola, that's where the vertex is going to lie. And then same over here. And then finally, you should be able to identify x and y intercepts on your graphs for all graphs, not just parabolas. These two graphs actually don't have x-intercepts, and so eventually we'll be getting back into what that means when a graph doesn't have an x-intercept. But they both have y-intercepts. This graph right here has a y-intercept right here at about 0.5. And then this graph right here also has a y-intercept right about 0, -5 for that one. Okay, so those are just some important parts of graphs that you should be able to identify at this point. Going below here, you can read that we're going to look at 3 different ways for graphing a quadratic. Again, today we're just looking at this first form, standard form. Next video we'll be looking at vertex form, and then we'll do one more video where we'll just review transformation rules, okay? Similar to what we did for absolute value functions. So now let's look at some examples. Again, just standard form is what we're looking at today. So this is your standard form once more. Y equals ax squared plus bx plus c. To find the axis of symmetry, when you're in standard form, you're going to take this formula, x equals negative b over 2a. And that should look familiar from last year because we used that formula last year. Once you find the axis of symmetry, which again is the equation for a vertical line, that's why it's in x equals form, then that's going to tell you the x-coordinate of the vertex as well. The x-coordinate of the vertex is just going to be this number that you get, negative b over 2a. And then to find the y-coordinate of the vertex, you're going to substitute this value back into your function and then solve for y. So we're going to practice doing this here on examples 1 and 2. I want you to identify several things for each of these functions here. We're going to identify, first of all, the vertex, then the axis of symmetry, and then the maximum or minimum value. Okay, so we're going to talk about would this parabola have a max or a min, and then finally we're going to describe the range of each function and practice using our interval notation for that. Okay, so for number 1 here, I have y equals 2x squared plus 8x minus 2. The first thing I want to do is just identify a, b, and c. So those are just going to be your coefficients. So your a value, your leading coefficient is 2. Your linear term has a coefficient of 8, and then your constant is negative 2. And so if we use our formula for our axis of symmetry, or our formula for the x-coordinate of the vertex, that's x equals negative b over 2a, plug into that, that would be x equals negative 8 over 2 times 2, which is going to give us negative 2. So that means that the x-coordinate of the vertex will be negative 2, and now I'm going to plug in negative 2 to my function to find my y-coordinate. So my y-coordinate is going to be y equals 2 times negative 2 squared plus 8 times negative 2 minus 2. So again, I'm going to take this negative 2 here that we found, and we're plugging it in for x down here and then right here. On a test, if you're graphing, you want to, again, be sure you can do that without a graphing calculator. So make sure you can find your x and y values without using your graphing calculator. Make sure you can do order of operations as well. Negative 2 squared is 4, so this would give us 2 times 4 plus 8 times negative 2 minus 2, which would be 8 minus 16 minus 2, which gives us negative 10. So that tells you that your vertex is located at negative 2, negative 10. We also know the axis of symmetry. The equation for the axis of symmetry is just going to be x equals our x-coordinate here, so it's going to be x equals negative 2. Make sure you say x equals, because if you don't say x equals, it's not really an axis of symmetry. It has to be a vertical line, so you have to start that with an x equals. And then finally, the max or min value. If you remember from last year, same with v's, we talked about the leading coefficient tells you whether or not your parabola is opening upwards or downwards. And so since our leading coefficient is a positive in this case, our parabola is going to look like this. It's going to be opening upwards. And so our vertex would be down here. We're going to have a minimum value for this one. The minimum value of your parabola just refers to the y value of the vertex. Well, we already found the y value of the vertex. It is negative 10, so we know this parabola has a minimum of negative 10. Okay, vertex down here is at negative 2, negative 10, so we're taking the y value for the minimum. And so that means the range of this parabola is going to be all numbers from negative 10 to positive infinity. The minimum y value is negative 10, and then it keeps going upwards forever, so that would be the range. Okay, I'd like you to pause the video and then try number 2 on your own, please. And then once you've filled out all this information on number 2, click play to check your answer. Okay, let's check and see how you did for number 2 here. And so for the vertex, again, a is negative 1, b is 6. So we're going to plug in to our formula x equals negative 6 divided by 2 times negative 1. So you should get an x value of positive 3. When you plug positive 3 in back for x to your function, you get 12 for y. Be careful when you're squaring 3. you're squaring 3 to get 9, but then there's a negative sign in front of that x, so that reverts this back to negative 9. So just be careful there. So you get a vertex of 3, 12, axis of symmetry at x equals 3. Your leading coefficient was a negative for this one, so that means the graph is going to be opening downwards, which means you have a maximum in this case. So a maximum at y equals 12, which means your range is going to be all y values from negative infinity all the way up to 12. So it would look like this in interval notation. Okay, so now that we've practiced identifying the vertex and other parts of the graph given the equation, now let's practice graphing. So to graph a function in standard form, we're just going to use t-charts to do this, and the first value we put in our t-chart is always going to be our vertex. So again, we're going to use our vertex formula to start out each of these graphs. So our vertex formula for this one, f of x equals negative x squared plus 2x plus 3, is going to be x equals negative b over 2a. Our b value is 2, so this would be negative 2 divided by 2 times our a value is negative 1. So that's going to put our vertex at positive 1. So vertex at positive 1, and now we'll go ahead and we'll make a t-chart. Positive 1 is my vertex, and then I can pick other values at 2 and 3 would work. And we're going to plug into, again, this equation here. Now again, for your homework, I don't mind if you use your calculator to find this, but just be prepared for a test where you wouldn't be allowed to use your graphing calculator per se. It might be a good idea to practice doing your plugging in this way just so you don't make any mistakes. Okay, so that's why I'm showing this here for your notes. So I plug in positive 1. I'm going to get 1 squared, which is 1, but then again you got a negative sign in front of that, so that reverts it back to negative 1 plus 2 plus 3. So this is going to give us 4 for our vertex, and then when we plug in a 2, we get negative 4 plus 4 plus 3, so that gives us the 0.23, and then finally when I plug in a 3, I get negative 9 plus 6 plus 3, that gives me 0. So I know I'm going to have a vertex at 1, 4. Good idea to draw on your axis of symmetry as well. Okay, and then I'm going to have points at 2, 3. And 3, 0. So I'll connect those dots, and this is going to be the right half of my parabola. And then to get the other half, remember I just have to reflect over my axis of symmetry, and so I'm going to go directly across. I'll have a point here at 0, 3, and then I'll have a point at negative 1, 0 to get the other half of my parabola. Your leading coefficient was negative, so that means your parabola should be opening downward, so this one looks okay. Just be sure you double check that, double check and make sure you made the vertex where it's supposed to be. Okay, one more down here for number 4. I'm going to have you click pause, try this one on your own, and then click play to check your answer. Okay, so for this one, your graph should look like mine here. Vertex, if you use your formula, you get a x coordinate at negative 2, and so then you're going to plug in negative 2, and then I chose 0 and 2 just so I could get numbers that would cancel out my 2 down here so I wouldn't have to deal with fractions. So when I plug those in, you can see my work here. You get negative 3, negative 1, and 5 respectively. So your vertex is going to be over here. Parabola is going to open upward because your leading coefficient was positive, and it's going to be a little wider than normal. And again, that's going to be based on the transformation rules that we'll get into in a couple of videos from now. Okay, one last thing that you want to do on your homework is you want to use your graphing calculator to check your graphs, just to make sure you're getting everything correct. So after you completely go through one graph, it's just a good idea to go through and check it on your calculator. So just a reminder, refresher of how to do that. So here's my graphing calculator screen. If I wanted to check this graph that I just did, I would just plug in, I've got f of x equals already, so my equation was 1/2 x squared, so we'll do a fraction, 1/2, arrow right, x squared, plus 2x, so plus 2x, and then minus 1. and then we'll just go ahead and we'll check that graph there. Okay, I'm going to get rid of this here so I can see. So my graph looks right here. Okay, it looks pretty good. Just double check and make sure your coordinates are in the same place. What you can do is you can hit this, you can use your menu trace feature. So if you hit menu and then you get number 5 trace and then 1 graph trace, you can actually type in the different values you got from your t-chart and see if you have points at the correct spots. So we found that our vertex was -2, -3. So now that I've got this menu trace feature up, I'm just going to type in -2, and it's going to bring up this box, x equals -2. I'll type that in, whoops, -2, and hit enter, and it shows me that I have a point at -2, -3, which looks like it's my vertex. I can then type in 0, hit enter, and it shows me I have a point at 0, -1, okay, which is where our point here is. And then finally I can do one more. I can type in 2, and it shows me I have a point at 2, 5, which is where this point right here is. So use that feature to go ahead and check your graphs for each one on your homework, just to make sure that everything is accurate. Okay, if you have any questions, feel free to watch through this video again, or just write them down and ask me the next time you see me. Until then, have a nice day. You're all wonderful people. Take care.